Day 3 is the first day where we have to think about how we're going to solve the problem. The first 2 days are pretty easy warm-ups, and this one requires some amount of thought. And because of that, this is the first day that I'm not solving again before I record this, so we're going to watch me solve it live, so it'll be a little bit clumsier. But solving this with the parsing expression grammars is really fun, I think. It's probably a different solution than you would use if you didn't have them, where you sort of iterate over one character at a time and accumulate or keep track of some state that you update. Instead, we're going to take advantage of the fact that parsing expression grammars track some state implicitly as they execute. So start with a peg like I always do, and we're going to match one or more of either a number or a blank or a symbol. And a number is going to be one or more digits, and we'll capture that with a single quote. A blank is something in the character set dot or new line, and a symbol is anything else. And because it shows up last in my choice here, I can just be lazy and say any character that didn't match already has got to be a symbol. And we'll test that out. Peg match test input. And I can see that it captured everything, but in order to solve this problem, to find numbers that are adjacent to symbols, we need to have some concept of where the numbers and where the symbols fall on this grid. So we can do this with a peg by capturing the line and the column. And then we run this. Oops. What did I do? Right. Group only takes one peg. You can't implicitly pass it multiple arguments like that. So this captures the line and the column. As you can see, they're one indexed, but that's fine because we'll only ever compare them to one another. So we actually don't have to think about their indexing scheme at all. So we also need to know where the number ends. So I'll capture column again, but that'll give me the position of the character one after the number, because that's where we are after we've parsed the number. So I'm going to use replace, and I'm going to give it a function called dec for decrement. This is just like the predecessor. It's not actually decrementing anything. I don't love the name because it's a pure function, but whatever. So now we have the line, the column, the number, which let's turn that into a actual number for math. Great, the number and then the end column. And when we parse a symbol, we want to do the same thing, but there's no, so I'll parse the line, I'll parse the column, and then there's no need to parse the end column because it's the same as the start column. It's only one character long. And then this is kind of a mess. So I'm going to add a tag to these. I'm just going to capture a constant and say this one is a number and this one is a symbol. And then I'll make it easier to use this after the fact. I don't have to, like, I know this one is length 4 and this one is length 3, but that's really messy. So what I'm going to do is take the input and not make the same mistake I made last time. And I'm going to loop over it. So we're going to do this imperatively. I think it's just the easiest way. Doing this as a fold is just going to be kind of complicated. So loop over the, I'll just call it the element in the parse result. And then I'm going to match on the element and say if it's a number, then that's line, start call, number, end call. I'm going to do one thing, and if it's a symbol, that'll be line, call, and symbol. And what I'm going to do is put these all into a lookup table. I don't know, there's maybe a better name for that, but I'm going to make an object, and I'm making it a table so that it is a single reference style object, and I'm going to have multiple references to it in the lookup table, so that if you look up the character at 1, 1, you get this 4, 6, 7, and if you look up the character at 1, 2, you get exactly the same object back. So even though this is not, we're not going to mutate it, tables are the way that you get reference equality. So I'm going to say the number is line, and there's no way to do this punning, so you just have to watch me type. Maybe value, but whatever. And then we're going to loop over every column in the inclusive range. So range is the exclusive range, range 2 is the inclusive range from start call to end call. We're going to put in the lookup table, we're going to put a tuple of the line and the column. That'll be our key. And we're going to put the number. So now we have multiple references to this single number object in our lookup table. And I'm going to do basically the same thing for symbol. So put line column, but this time the symbol can just be symbol, symbol, line, line, call, call. And great. And just to test this, I'm going to say in lookup, let's say 1, 1. And in lookup, actually 1, 2 is a lot more interesting. In lookup to 4. And we'll test solving that. Great, so I got the number back, and I got that back. Okay. So what the problem actually wants us to do is find all of the numbers that are next to a symbol. So what I'm going to do is say, define what next to means. So I'll say neighbors, and this will give me a number. So I want the line, the start call, the end call. And the neighbors of this are going to be trying to think of like the neatest way to write this, but we're going to use a list comprehension, and we'll say line in range to, and we'll start with, so from line -1, so decline, to line +1, incline. So that'll give us like the line before and the line itself and the line after. And then also column in range to dec start call to inc end call. So this is going to give us kind of not the neighbors, but the big grid that includes the thing itself. So I'm going to say to exclude those numbers that are like within the number itself and not next to it, I'll say when line, I'll call this L and C just so that I don't have this shadowing problem. So when line is L and call, there's no like single in range function, so we'll say greater than or equal to start call, less than or equal to end call. And then we want to invert this. I think actually I can use unless, and that'll invert the condition for me. I think that's a loop syntax. And we'll capture LC. And definitely test that one. So test it with, do I have, yeah. Let's copy this and use it as my test case. And that did not work because I referred to call. Okay, so I realize 0, 0 is not valid in the grid, but the lookup table is sparse anyway, so it doesn't care about that. We can refer to keys that don't exist. So I'm seeing that I have 1, 0 and 1, 4, but I don't have 1, 2, 1, 3. So that looks right to me. I think that's good. So, having found all of the neighbors, I want to now, this is like a little bit gross, but let's just make a separate lookup for this, and we'll just store references to the same ones. So def number, and we'll say array push numbers number. This way we could just have an easy way to look up all of the symbols and numbers without having to loop through this. Symbol and array push symbols symbol. So now, I wish we had like an easy way. I'm gonna add this. We'll just check if it has a number to decide if it's a symbol. That's fine. So loop over these, and now loop over each number in numbers. And we're going to take the neighbors of the number and so nested loop of line call, or I'll just call this point because I'm going to look it up by point anyway. We'll say let neighbor be in lookup point. And we'll say when there is a neighbor. So we're looking for things with symbols. So we'll say where the neighbor is not nil, because this could have given us nil, and neighbor symbol. And that'll give us either nil if it's a number that we're looking at, or it will give us the symbol, which is always truthy. Only nil and false are truthy. No keyword is truthy. Sorry, falsy. And if we find that, this is actually, once again, going to be a sum loop. I think there's actually a way to do this where we break out of the loop, out of the inner loop, but I'm not actually sure. So what I would make sure that we do is we don't double count the number if it's adjacent to multiple symbols. And the way that I wrote this, it actually is going to do that. So I'm actually just going to say like has symbol neighbor for the number and give that the lookup table. And then it's just going to be this exact inner loop. So defen has neighbors. This is going to be a number and the lookup table. And we're going to use the fold loop helper that I wrote. And we're going to start with true. Our fold function is going to be all. Our fold function is going to be and, sorry. So this will be and 0, 1. So and is a macro, so when you want to pass it as a first class function like this, you actually have to wrap it. That's like a very easy Janet mistake to make, is to try to like pass and to a loop function. So I don't need this when anymore. I can just use that as my condition. But maybe when neighbor is kind of nice. And of course I want that to be or and start with false. Doing great. And I want to say truthy symbol, or I think I can actually now, there's a new thing that's like has key, I think. Try that. It doesn't compile, which is fine. Cool. This reads kind of badly to me. A little better. Okay, so now let's go and fix up this thing that used it. When you have the neighbor, then we'll take the number from the number. Okay. What did I actually call it? I'm just going to call this next to symbol. That's better. When next to symbol. Oh, same typo. Okay. So I got the answer of 4361. I feel like that can't possibly be correct, but let's check this. 4361. Okay. I guess it worked. And let's try the real input. 259,618. Yeah. All right. So part 2 is a little bit harder. So what part 2 asks us to do is we're going to find all of the symbols that are stars that are adjacent to 2 numbers. And this is actually why I made this lookup table have everything in it. So we can do this. So I'm going to write this as we'll just call this like parse input. Take the input, do this part, and then return lookup symbols and numbers. I'll say lookup symbols numbers are parse input. We can just get rid of all of that. And see if I broke it. I did not. And part 2 is going to be very similar. In the beginning. So get that out of here. Except that now what we want to do is look up all of the symbol and symbols when symbol. You can just write it like this, by the way, to look up a key and a value, but I find it, I don't know, I go back and forth. I used to prefer that, and now I always use in to look it up. It makes it easier to add a default, but I don't really have a principled reason to prefer one or the other. So when, I just took it out for no reason. When this is equal to a gear, so we only want to consider gears. And then I want to find like adjacent numbers. I'm going to say let adjacent numbers be, you know, find adjacent numbers from the symbol and the lookup table. So all this adjacent numbers. It will take a symbol, but really all I want is the line and the column. And I want the lookup. So I could just write, in fact I will, because I'm lazy. Line, start call, call, end call, call as a way to get the neighbors. So we will seek for, oops. For each point in the neighbors of the symbol that we're currently looking at, I want to look up, I keep using the wrong brackets. It's a lot harder to type when you have to think about what you're writing and talk at the same time. So in the lookup table, look up the point, get the neighbor, and this is going to give us all of the neighbors. Don't need that let in there. We can just return that. Seek, but I want this to be... Oh, I see why I started writing it that way. Okay. Doing great. When neighbor is not nil, neighbor. So this is going to give us duplicates, which is not what we want. So I'm going to, I think it's unique. Doc unique. It's not unique. Is it unique? There is a function to only get the distinct elements from a list, and I don't remember what it is. So let's look it up in the docs. So go to this wonderful page, which is the core API documentation, just somewhere here. I clicked the wrong link. So this will give us like unique, distinct. Look, it is distinct. Huh. Okay, I don't know. Do I not have doc strings? Oh, right, I'm dumb. Doc actually doesn't return the doc string. Doc prints it to standard out, so it did work, but I couldn't test it. So what I should have done is test standard out. And that worked if the rest of it had actually compiled. So you can see that it printed out the docs. Get a hint of how much I actually use this Emacs judge workflow when I'm not recording myself. So take unique and distinct it. Great. And this is now, I'm taking the sum loop of this symbol, but actually what I want to do is say when, so we only want ones when it's exactly 2. So when the length of the adjacent numbers is 2, so only gears that are directly next to 2 numbers. So this is a good example. 4, 6, 7, and 35. And I'm just going to return it for now, just so I can debug this. Oops. Did not balance my parents. Okay, so that gave me the symbol at line 2, column 4, and line 9, column 6. I'm just looking at the test input. And yeah, that would be that guy. That seems right. Okay. And if I remember right, what we want to do is take the product of the 2 numbers. Take the product of the 2 numbers and sum all of those products. So once again, it becomes a sum loop. Take the product of the adjacent numbers. Sum loop that. And yes. These are the numbers themselves, so we want to map to actually just take the number key from them. This is something, by the way, I like to have this. This is not standard Janet, but I like to have this first class function. Just because you end up, I don't know, like mapping with a single key a lot. So same thing. So 467835. 467835 looks good. Solve that with the real input. Yeah, that looks right. Okay, so that worked. So yeah, that was a lot harder to do while narrating and talking, as you could, I'm sure, tell from how much more slowly I was working. But I think that this capturing lines and columns and pegs is pretty neat. I think the obvious way to do this without pegs would be to iterate over this as a grid, and like every time you encounter a new line, you increment the current line and reset the column, and every time you don't, you like increment the column and just basically keep track of line and column yourself. And I like that pegs do that for you. And I don't think I have any other interesting like things to add to this. I think this building of the lookup table, it's if we were only putting each thing in one place, there's this neat helper called tab seek, which is like a loop macro that takes the same like syntax I've been using this whole time. So like element in 1, 2, 3, and you give it two expressions. You can say like element, and then element times 2. And if we look at what that gives us, it gives us back this table, which is maybe kind of hard to read because these are the same type, but the key and then the value that we got from this. But tab seek, there's no like tab cat seek or something that we could use to put each of these values in multiple different keys in the array. So I think that's the cleanest way to do it that I can think of. All right, I think day 4 might be interesting again, so I'll see you on that one.